Have you ever been, trying to learn something new, maybe getting your head around a complex report for work or picking up a completely new skill, and you just felt like your brain was completely full?
Hmm.
Like you've hit some kind of invisible wall, and no matter how hard you try, the information just won't stick.
Yeah, definitely. Or maybe sat through a lesson that felt way harder than it needed to be.
Exactly. Not because the topic itself is rocket science, but just
Yeah.
the way it was presented felt confusing.
Right.
Well, if any of that sounds familiar, you're definitely in the right place today. We're doing a deep dive into something called cognitive load theory, or CLT.
Developed by John Sweller back in the late 80s. And it's this, well, really insightful framework from educational psychology.
It really helps us understand why learning can sometimes feel like such an uphill battle, and maybe more importantly, how we can actually make it easier and much more efficient.
Absolutely.
So our mission today is to give you a kind of powerful lens. We're going to unpack the frankly surprising way our memory actually works. We'll identify the different kinds of, let's call it mental baggage we carry when we're trying to learn.
Yeah, the different loads.
And then the best part, share some really practical strategies to lighten that load. The idea is to give you a shortcut to optimizing how you learn or how you help others learn, whether you're teaching, designing something, or just, trying to pick up something new yourself.
Super useful stuff.
Okay, so to really get how to learn better, we kind of need to start with the basics of how our brain is set up for learning. CLT talks a lot about our cognitive architecture, especially working memory. Can you maybe paint a picture of that for us? Why is it so critical?
Absolutely. So think of your working memory as like your brain's mental countertop or workspace. It's where you're actively juggling information right now.
Okay.
But here's the kicker, and this is where that info overload feeling really comes from. It's incredibly limited, seriously
How
limited.
limited are we talking?
Well, most research suggests it can only handle a few chunks of new information simultaneously, maybe like 4 to 7 pieces, and only for a really short time, maybe seconds.
Ah, okay. So that's why you can maybe remember a phone number for a moment, but if someone lists off 7 shopping items?
Exactly. You'll probably lose half of them by the time you look for a pen. Your workspace just gets completely swamped. It's a real bottleneck.
Right, the bottleneck. But then we also have long-term memory, which is different, isn't it?
Totally different. Contrast that tiny workspace with your long-term memory. That's the brain's vast, essentially unlimited vault, like a huge library.
Okay, unlimited. That sounds better.
It is. And crucially, it stores knowledge not just randomly, but in these organized structures we call schemas.
Schemas,
Yeah.
like mental frameworks?
Exactly. Mental models, frameworks, templates, whatever you want to call them. They're these interconnected networks of information, and they are vital because they act like mental shortcuts. Well, once you have a solid schema for something, say driving a car, you can perform that complex action almost automatically with very little conscious effort in your working memory. The schema handles it. It frees up your working memory.
That makes perfect sense. So working memory is limited, active bit. Long-term memory is the huge organized library with these schemas. Then learning,
Mhm.
the actual act of learning, is basically taking new info from that limited working memory and somehow getting it filed away correctly into long-term memory as these useful schemas.
Precisely. That's the goal. The whole point of effective teaching or effective self-learning is to make that transfer, that encoding process as smooth and efficient as possible. Move it from the fragile workspace to the permanent library.
Got it. Okay, so we have this picture. Small workspace, big library, and the goal is efficient filing, which naturally leads to the question, what kind of mental effort are we actually dealing with when we learn? You mentioned load earlier. CLT breaks that down.
Yeah.
Because it feels like not all effort is the same.
You're spot on. Not all effort is created equal. CLT identifies 3 distinct types of cognitive load that all add up to the total strain on your working memory.
Okay, what's the first one?
The first is intrinsic load. Think of this as the load imposed by the sheer inherent difficulty or complexity of the material itself. How many elements are involved and how much do they interact?
So like learning basic addition versus learning quantum physics.
Exactly. Quantum physics just is inherently more complex. It has a higher intrinsic load. You can't really eliminate this load entirely. The topic is what it is.
Right, you can't make quantum physics simple.
No, but, and this is key, you can manage it. You can use smart instructional strategies like a mat of scaffolding, providing support that you gradually take away, or careful sequencing, presenting things in a logical, step-by-step way. It's about making the complex climb manageable, not removing the mountain itself.
Okay, managing the unavoidable difficulty. That makes sense.
What's next?
Next up is extraneous load. And this one, well, this is generally seen as the bad
The
load.
bad load. Why? Because it's the unnecessary burden. It's cognitive load caused by how the information is presented, not the information itself. Think poor instructional design, confusing layouts, irrelevant pictures, annoying background music, anything that makes your brain work unnecessarily hard on things other than learning.
I think we've all been there.
Right.
Like trying to understand a super cluttered diagram with way too much text or instructions that are just baffling.
Absolutely. Or maybe text on a slide that someone is just reading aloud word for word. That's often extraneous. It's mental effort spent deciphering the presentation instead of processing the content.
So this is the load we should aim to reduce or even get rid of.
Yes.
Mm.
Minimize or eliminate it wherever possible. Every bit of working memory capacity wasted on extraneous load is capacity not available for actual understanding and learning. It's like mental static interfering with the signal.
Okay, intrinsic is the necessary difficulty. Extraneous is the unnecessary noise. What's the third one?
The third type is germane load. And this is the good load. This is the beneficial effort.
The good load. How can load be good?
Because this is the mental effort that's directly involved in the process of learning itself specifically, in constructing and automating those schemas in your long-term memory. It's the deep processing, making connections, understanding relationships. That's germane load.
Ah, okay. So this is the effort that actually leads to understanding and remembering.
Precisely. This is the productive struggle, the effort that builds robust, lasting knowledge. But here's the really crucial interaction between the three. You can only really foster and optimize this good germane load effectively after you've managed the intrinsic load and minimized the extraneous load.
So you need to clear the decks first.
Exactly. You have to manage the inherent complexity and cut out the confusing clutter to free up enough mental bandwidth, enough working memory capacity for the brain to do the deep work of schema building. It's like needing a clear desk before you can really focus on a complex project. You got to declutter first.
That framework, intrinsic, extraneous, germane, that really reframes how you think about why some learning works and some doesn't. But just knowing the types isn't enough, is it? The real power isn't applying it. So what are some practical strategies derived from CLT that we can actually use?
Right, let's get practical. One of the most fundamental strategies directly addressing that working memory limit is segmenting.
Breaking things down.
Yep, breaking information into smaller, more manageable chunks or segments. Instead of one long, dense lecture or chapter, present it in focused parts. Allows the learner to process one bit, maybe consolidate it before moving to the next. It avoids overwhelming the system.
Yeah, you feel that intuitively, don't you?
Yeah.
A wall of text versus clear paragraphs and headings. Much easier.
Yeah.
Okay, what else?
Another big one is the modality effect. This is about using both visual and auditory channels effectively.
So pictures and spoken words together.
Kind of, yeah. The idea is that our working memory has somewhat separate channels for processing visual and auditory information. So if you present some information visually, like a diagram, and complementary information auditorily, like narration explaining it, you can effectively use more processing capacity than if you just put everything visually, like text in a diagram.
So like narrating a diagram is better than just having the diagram with lots of text labels on it.
Often, yes. Especially if the text just repeats the narration. The key is complementary information. Where it can go wrong, though, is if the visual and audio are just redundant saying exactly the same thing, or if they conflict. That can actually increase extraneous load.
Got it. So use both channels, but make sure they work together, not just repeat or clash.
Yeah.
Makes sense. What about worked examples? I've heard that term.
Worked examples are fantastic, especially for beginners learning procedures or problem solving. Instead of just giving them a problem and saying solve it, you first show them a detailed step-by-step solution to a similar problem.
You walk them through it first.
Exactly. It guides their attention to the important steps and helps them build an initial schema for how to solve that type of problem correctly without getting lost in trial and error, which can be very taxing on working memory.
Okay, so you show them how it's done properly first, and then presumably you let them try.
Precisely. Which leads nicely into the next strategy, fading guidance.
Fading.
Well,
So you gradually pull back the support.
yep. You start with fully worked examples, then maybe give them partially completed examples, and then eventually have them solve problems entirely on their own. It's a gradual transition from full support to independence as they gain expertise and build those schemas.
Scaffolding, like you mentioned earlier.
Exactly. Fading is a form of scaffolding. And one more really critical one, eliminating redundancy.
Avoiding repeating stuff.
Yes. It seems counterintuitive sometimes. People think presenting the same info in multiple ways must be helpful, right? Like
Right.
having text on a slide and reading that exact same text aloud.
Yeah. Seems like reinforcement.
But often it's not. If the information is truly identical and presented simultaneously through different channels, like reading text that's also displayed, the brain has to process both, reconcile them, and it actually increases extraneous load. It forces the learner to mentally cross-reference unnecessarily. If the text adds something the narration doesn't, or vice versa, fine, but pure duplication, usually bad.
Wow. Okay. Less can definitely be more then. Avoid making the brain do pointless work.
That's a great way to put it.
So these strategies, they sound powerful. And it strikes me this isn't just about schools and classrooms. Where else does cognitive load theory really make a difference out there in the real world?
Oh, its applications are incredibly broad. Of course, in education, it's fundamental. Designing lessons, textbooks, online courses all benefit hugely from applying these principles to reduce that bad extraneous load and manage the intrinsic load so students can actually focus on the learning the germane part.
Making sure the teaching method isn't actually getting in the way.
Exactly. And then think about workplace training, super critical there. Creating training materials, safety procedures, software tutorials. You want people to learn quickly and accurately, especially in complex or high-stakes jobs. Think pilots, surgeons, technicians.
Yeah, you don't want them overloaded while learning critical procedures.
Absolutely not. Minimizing cognitive load during training can literally save lives or prevent costly errors. Even just onboarding new employees, efficiently good CLT-informed design makes a huge difference.
You see it in tech too, right? Like app design.
Definitely. UX design, user experience design, relies heavily on CLT principles, even if they don't always call it that. Why do some apps or websites just feel intuitive and easy to use while others are confusing and frustrating?
Yeah.
A lot of it comes down to how well they manage your cognitive load. Simple layouts, clear navigation, progressive disclosure of information. It's all about reducing the mental effort needed just to use the thing so you can focus on your actual goal.
That makes so much sense. A cluttered website feels effortful because it is creating extraneous load. Okay, so education, training, UX. What about for us, just individually?
Well, that's maybe the most empowering part. Think about how you learn new things, how you consume information. You can apply these ideas yourself.
How so?
When you're tackling a complex report, maybe break it down consciously. Look for summaries first. When learning a new skill online, maybe choose tutorials that are well segmented and don't bombard you. Even when you have to explain something complex to someone else, think, how can I present this to minimize their extraneous load? How can I sequence it logically?
Right. Making yourself a better teacher or communicator by managing their load.
Exactly. It's a really versatile toolkit.
So wrapping this up then, understanding cognitive load theory, it really gives you this powerful lens, doesn't it, for seeing why some learning just clicks and other times it's just frustrating. It equips you not just to learn better yourself, but also to see how to make information clearer, more concise, more accessible for other people too. It's really about being smarter with our brain's limited bandwidth.
Well said. It's about making the path to understanding smoother.
So maybe a final thought for everyone listening to chew on.
Yeah.
Now that you understand these different types of cognitive load, the necessary intrinsic, the problematic extraneous, and the valuable germane, how might you consciously try to restructure your own daily information diet?
Ooh, interesting question.
Yeah, think about everything from news articles and emails to maybe online courses or even just scrolling through social media. How could you actively try to prioritize that germane load, the real learning and understanding, and deliberately minimize all that extraneous noise and distraction?